Newton's laws of motion. The agenda is to explore only the concept of what you meant by change in linear momentum. That's it. Now, here actually the change in momentum, linear momentum means final linear momentum minus initial linear momentum. That is called as change in linear momentum. As the linear momentum is a vector form, therefore it will try to obey vector parallelogram law of subtraction because minus is there. Next one is this change in momentum magnitudically and directionally also equal to the j. J is nothing but what? Linear impulse of the system. Now, anyways, let us try to explore different cases in the change in linear momentum. First, example number 1. In the example number 1, let us consider that on the floor, a massive object of m moving with a velocity of u bar changes to the velocity of v bar, then both are moving in the same direction. Therefore, in this case, change in linear momentum is equal to mass of the object is constant, final velocity minus initial velocity you have to take. So velocity means vector, therefore I wrote here bar bar. So both are moving in what direction here? X-axis only. So therefore it is necessary to represent this delta x, delta p changes according to what direction? X direction. That is the first example. Let us consider second example. In the second example, okay, suppose here is the floor and here is the object having mass m and u is the initial speed. Now here is something like a wall. Now this object moving towards the wall bounces here and then return back with the same magnitude of speed. In such a case, the change in linear momentum is given by delta p bar is equal to mass of object is constant, final velocity is in the direction of negative x-axis, therefore minus ui you have to write down, and initial velocity in the forward direction, therefore minus of plus ui you have to write down. Upon making common, you can write down as a minus 2u mi cap. That is the formula for the change in momentum in the second case. Now let us consider the third case. Now here is an object having initial mass of m, initially moving with the speed of u bar in this direction. Now, because of external agency, suddenly it changes direction with the same speed u but in this direction. Then how do you calculate change in linear momentum? Under such a condition, the change in linear momentum is given by delta p bar is equal to finally along the x-axis. Therefore, m into u I cap, initially moving along what direction? Y direction. Therefore, you can write down as a minus a u j cap you can write down. So therefore, you can write down as m u of, you can write down as I minus j, or you can write down as mu into root 2. So by using this particular formula, one can decide the change in linear momentum. Now let us consider in the next step. Point number 4. Suppose there is something like a wall and this is the origin what we are considering. A ball is moving towards the wall with the speed of u having mass m. Now it is bounced back in this direction with the same speed of u, mass not changing, same mass m. Under such a condition, we need to find out the change in momentum. Now let us consider the ball makes an angle of theta degrees with the wall, and regarding bouncing also it is doing the same component of theta degrees. Under such a condition, you can resolve this one into components. So how do you resolve into components? First initial vector divided into components. So this is along in this direction we have py initial. Now along in this direction we have px initial component is there. Now when you consider this particular condition, in this particular case along this direction py final component is there, along this direction Px final component is present. No doubt that is the linear momentum of object is divided into here two components. Let us consider that the change in momentum. When you consider the change in momentum delta P along x direction, let us take. So final value minus initial value we have to take. So therefore, final value along x direction means negative side. Therefore, you can write down as mu of minus I minus of mu of initial will be along positive x direction. Therefore, you can write down as plus I cap, which is equal to minus 2 mu I cap. You can write down by using this data. Now let us consider the next task, the change in momentum along y direction. Same to same case, final minus initial. So final value is along the positive direction. Therefore, mu of plus j linear momentum. And the initial also object component will be in the same direction. Therefore, you can add on as mu of plus j. Therefore, you can add on as 0 vector or 0. That means the change in momentum is exist along only horizontal direction. Like this, you can take now. In the examination, suppose some other angle is given with the origin like this. Suppose here is the ball we have, and these are normal, and a ball is moving with a speed of u, maintaining an angle of theta degrees, and it moves at an angle of alpha degrees during the bouncing process. Speed of the object is not changing. Then in such a case, how do you find out the change in momentum of the system? Now in this given case, let us try to resolve along the components. So by resolving into components, we have here angle theta means here angle also theta is there. Therefore, you can write down as mu cos theta in this direction. And this is mu sin theta we can write down. Here what we have alpha degrees. So therefore, when you try to prepare like this, okay, here angle alpha will come. Here you can write down as mu cos alpha you can write down, and here you can write down as mu sin alpha we can write down like this. Now, in the given case, let us try to find out first of all change of momentum along x component. In such a case, along x direction, this is the final component. Therefore, mu common you can prepare as sin alpha minus you can write down as sin theta in the problem. And similarly, along y direction, let us try to find out. Along y direction means along y direction means finally it is moving along forward direction. Both are moving in the same direction only. Therefore, I'm just comparing simply I cap here for x component. For y component, final velocity is upside, initial velocity is downside. Therefore, mu of you can write down as cos alpha. Okay, upside means j cap minus of you can write down as cos theta of minus j. Here you can write down minus j. Minus of minus will become plus and j will comes outside. Therefore, you can write down as mu of cos alpha plus cos theta of j we can write down. Now, what is the change in momentum? Suppose they will ask. Change in momentum magnitude is equal to root of delta p x square plus delta p y square. Like that, you can write down the change in linear momentum. And let us see one simple example question. One example question. Suppose here is a wall and an object is moving having mass m, okay, moving with a speed of u towards the wall and return back with a speed of v. What is the change in momentum? Suppose we need to calculate. So the change in momentum in the problem given by delta p change in momentum is equal to final momentum minus initial momentum. Final momentum means object is moving in the negative x direction. Therefore, you can write down as mv of minus I we can write down minus of initial will be mu of plus I we can write down. Now in the given case you can write down as what m common, then what do you write down here? Minus v minus u of I, or otherwise you can make minus common, minus m of v plus u of I. This is going to be the correct in the form of vector, so therefore you take bar here. Okay, right. What is the magnitude? Suppose they ask, magnitude means only value. Delta p magnitude, delta p magnitude means m into v plus u is the ultimate answer, magnitude. Like that, a simple question. Thank you for watching my video. Please subscribe my channel for further updates. Jai Hind.